Welcome everyone. We're glad to have Terry Walsh with us this evening. Terry is a Casio advisory teacher from the Denver area. He has been actively involved with Casio technology and pre-AP workshops around the country, and we're looking forward to hearing a bit more about scatter plots and lines of best fit. My name is Lori McPhee, and I'll be the moderator this evening. So if you have any questions during the broadcast, you are more than welcome to enter them into the question pane, and I will do my best to answer you. For audio quality, your microphones have been muted. So now, without any hesitation, I'm going to turn it over to Terry.
Hi, thanks, Lori, and welcome everyone. I hope I don't cough too much. I've developed a little tickle in my throat this afternoon. So this webinar is looking at some data and scatter plots and lines of best fit. As you can see from my Prism emulator, I'm going to do some line of best fit, and I've got modified practice on there. In the other webinars that I've done, I've had a number of different questions that we've explored on previewing calculus and some other topics. In this webinar, it's going to be a little bit different. We're really going to spend most of the time just looking at this data. We're going to look at it in two different ways. And the way I'm planning the webinar is I'm going to show you some things as a demonstration, and then I'm going to go back and change some things and let you see how I got to what I'm going to show you to start with. So this is some data that I actually took out of a textbook when I was doing a workshop in Texas. And it shows the minutes that students studied for a test and the score that they got on the test. I added the two pairs of points that are in red. But one of the questions to ask is just what's the dependent variable, what's the independent variable? And that can be an interesting question, especially for your students, because students might be more interested in how much time do I have to study for a certain score, in which case they could say they want to make the score the dependent variable or the independent variable, and then the number of minutes they have to study the dependent variable. And that's actually what we're going to do when I go in and show you how I set up the emulator to get to the things I'm going to show you. So for right now, for the first graph that we're going to look at, the dependent variable is score, the independent variable is time. And again, that's probably the more common. But what you would need to do is go into the stats mode on the calculator, and I'm not going to do that. I'm not going to press menu and go into statistics. I've actually set this up as an E-activity, and come to think of it, that's going to be my next webinar, so I'm plugging myself a little bit. This first strip up here where it says score versus minutes studied, it shows the statistics table. So that's, if I enter that, that's highlighted right now. I can go from highlighting one of these to the next by the up and down arrows. If I hit enter, this is just the list. I've just entered the list of data into the calculator. I also put in minutes and score up at the top in this subheading. You probably know that if you put that information into your calculator, you still have to use just the number list. You cannot use the name of the list that you put it in there. And then I've also gone in and coded two of them, the two pairs that I have colored in slightly different colors of red in both of them. If I were to hit graph for F1 when I'm in the statistics mode, I've already set it up, and I'm going to go into that again later, so I'll show you how to do that. I'm just going to say, let's look at graph 1. I've already done some work here, and this is the scatter plot. So the first question is, why do I have these 2 points in different colors? This one I think is a little more obviously an outlier than the other red one, but they both could be considered outliers, whether or not you want to leave that one as an outlier or leave it included. But I've added these, and in my mind they're outliers. I want to look at the data that's very linear, and what I want to do is find a line of best fit for only the black data points. I want to ignore the two red ones. And the reason I always put in at least one or two outliers like this is that way if the students just go in and calculate the line of best fit, that's not what I want them to do in this type of problem. I'm looking at problems for middle school or maybe Algebra 1 or Algebra 1 in middle school, where currently what you might do is have the students graph on paper and then use a string or a ruler or a piece of spaghetti to estimate a line of best fit and then write the equation from their problems. I'm still saying that's good mathematics to do, but after the students have done some of those, I've got a list of questions and I want to spend more time analyzing what the line of best fit tells me and asking questions about it instead of spending a lot of class time plotting the points and drawing or figuring out a line of best fit with a piece of spaghetti and then having to calculate everything. In this mode, in the stats mode, I can trace my data points if I hit shift to get to the standard F keys rules. So if I want to trace, it's just going to go through the different data points by hitting the left and right arrow. But really, the only purpose for this is I want to use this screen in my graphing mode so that I can use modify. So I'm going to jump out of this part of the E activity and go down to where I'm actually looking at the line of best fit. And if I hit modify, this is the same window that I had before, but now if I hit trace, the only thing I'm tracing is on my line. So actually right now I'm in modify, so I can't do that. But I cannot trace the data points because they're just background. This whole graph is background. And I'm using the same window, and you'll see how that works when we do the revisions. So what I want students to do, and let's get back to the equation, I want students to figure out the line of best fit. I did it in Y2, so it comes out red. I wrote it as Y equals mx plus b. That's the same standard slope-intercept form that students are used to. If I hit draw, which is what you probably do more often than not, it's just going to draw the graph of whatever values happen to be there for m and x. I've already set them both to be 0. But if I hit F5 for modify, that's where I get these three things in this case in the lower left-hand corner. So first question I'm going to have for you, if I'm going to try and figure out the line of best fit, is what would you guess for the intercept of that line? And once I'm in modify, if I hit the right arrow, it gets up one bigger because it's step 1. If I hit the left arrow, it goes to -1. So I'm not going to do that. I'm going to say, and actually that's changing the slope right now. So in a line like this one, I work with teachers and students and say it's really easier to figure out the intercept first. So let's say somebody's going to guess 50 for the intercept. So all I've done is entered 50. And just like in trace, when you enter a value, if you have not used modify before, it sets up whatever variable you've got listed and it looks just like it does for trace. So I'm going to hit execute, and that's going to do two things. It draws my line where I set m equals 0 and b equals 0 last night, actually, when I had this all set up. But it also draws the line on the x-axis. There's a yellow line right here going through the x-axis, which is where the red line was when I had b equals 0. So that's not a bad first guess. So anybody want to guess a value for what the slope might be? Okay, somebody typed in 0.5. And again, you see here's the last line that was drawn, and here's the new one. That seems a little bit low. Somebody else had said 0.75 now. That's getting better. Oh, California pipes in with 0.9, so we'll try 0.9. That's not bad, but I'm going to say two things. That's not quite a good enough slope, but I'm also going to say that the intercept should be bigger. So some students might say, let's try 55. Again, that looks pretty good. Now, one thing that you can do, I know what the right answer is. I know I've calculated the line of best fit without the two outliers. So I know that the correct answer is y equals 0.974350x plus 51.98 and some other values. So I know what I'm looking for. But on the other hand, if I have a group of students that are working pretty hard and they get to that, I might well let them use that value. But for right now, I want to say let's use 52 as the intercept and move up and make the slope 1. And I'm going to hit exit, which is going to get me out of modify mode. After I hit exit, these are going to disappear, modify is going to disappear, and the line will remain. And now I've got the regular look of a graph. So I've really got a linear graph with a background of the statistics scatter plot. So I can trace in here. And then the only thing I can trace is on the line, but I can do some different tracing and go anywhere I wanted. I could say what happens at 30 minutes, and that's going to give me a score of 82. My question about the line, though, is I'm going to analyze the line a little bit. Like I said at the beginning, I want to look at what other information I can get besides just what's the line of best fit and then what happens at 30 minutes or 25 minutes or what expected values you would get. And one of the people that really influenced how I ask questions about things, about graphs especially, is Paul Forrester, who was a teacher in Texas who just recently retired, but he wrote a number of books, and in his books, in his problems, he never just asks one question. But he almost always will ask, what is the slope and what's the significance of the slope, and what can you say about the x and y intercepts if there are one. So one question to ask is, what are the units of the slope of the line of best fit? Well, again, remember we made time, so this is minutes. It's not labeled, but this would be minutes, and this is score. So this is your score per minute studied. So it gives you some idea of how quickly you're getting how quickly your score is improving. And actually this one with the data we had, it says the slope was 1, if you remember that. So that says every minute you study, your score goes up 1 point for every minute you study. Now, it's not a y equals x looking line. It's not a 45-degree angle because I've got a vertical axis going up to 110 and horizontal axis only going to 50. So that's why it doesn't look like that kind of a line. What does the slope of the line of best fit tell us about the problem? Like I've already said, it says how many points per minute you have. What is the y-intercept of the line of best fit? Looks like it's about 50 here, but I know when I entered it, I can answer that without using trace, or I can trace, and if I hit execute after what I did there is I hit F1 for trace, entered 0, pressed 0, execute, and that got to that point, and I just pressed 0 again to label the point. So that's the 052, so that's 52, so the y-intercept is just 50. But again, thanks to Paul Forrester, what is the significance of that? Like, if you think about it, that's 0 minutes studied gets a 52. So what we're saying is, in this scenario, if you didn't study at all, you'd get a 52. You'd probably, I mean, it's not going to be passing, but you'd get 52 points. When I've used this problem with teachers, the question I have for teachers is that a reasonable score for 0 minutes of study? And most of the time, the teachers aren't necessarily happy for most of the teachers, but somebody finally says, well, you know, if you've been paying attention in class and yeah, you didn't study, but you already knew some of the stuff, so maybe 52 points isn't too bad. But that might be an interesting thing to look at some of your own test scores, is if you took that kind of this kind of a survey with your students. All right, to the nearest second, how long would somebody need to study in order to get 100? Now, I've got these questions. I'm going to show you the answers to all of these. Since this is being recorded, you don't have to write any of these problems down. So I will show you later on. I'll have the answers and the questions show up on here, and I'll leave them up for enough time so that you can get them and copy it later if you want to watch it, if you want to re-watch this instead of trying to write anything down now. But to the nearest second, how long would you need to get to 100%, and explain how you got your answer. All right, the way I'm going to get the now you could look at it, 100% is up here, so it's somewhere about whatever that data point is. But I'm going to use the GSAL feature on the Prism. And again, in a classroom situation, you could have a student come up and do this. If your students all have Prisms, they could be doing this at their desks, or somebody could come up and push buttons on the emulator. But if I'm going to GSolve, that's not what I'm looking for. Is finding out my X value if I know my Y value is 100. So I want to calculate the X, which, the first couple of times you use this feature, you're thinking, wait a minute, I know what, it's kind of the reverse of trace. It's untracing maybe, but it's calculating an X for a given Y. So I'm going to enter 100 and press execute, and it gives me 48 minutes. So if I hit execute again, that labels that point. So how I got my answer was I used the GSolve. Another way you could do that is solve the equation once you've got your equation, and we're using y equals 1x plus 52. So just solve that for 100 equals x plus 52. The question again for students is, does studying for this amount of time guarantee getting 100%? And justify your reply. One of the things I've learned from doing pre-AP work for College Board is the importance of justify and explain what students are doing. So it's not just tell me an answer. It's not just give me an answer of do they think studying for that amount of time guarantees it, but justify the answer. And the answer is no, obviously, because there's a lot of other factors that go into things besides studying for 48 minutes. Some students could study for 20 minutes and get 100. This student studied for 29 minutes and got close to 100. Other students, if they quote-unquote study for 2 hours and don't really know about a third of the material, they're not going to score well at all. What do you predict the score would be for a student who studied 40 minutes? Okay, I just want to do a trace here. And I'm given 40 minutes, so I'm just going to enter 40 for X. And that's going to be a score of 92 minutes. Again, I'm going to keep track of some of these points. How long should I study if I wanted to score 70 points? Again, I'm going to have to go back to GSolve. So I would purposely ask questions once students knew how to get into the GSolve and find and calculate your X value. I would purposely ask questions that go back and forth. So 18 minutes should get me a 70. An interesting one is it's come up when I've done this with teachers is what happens if you put in a negative number? So what does the line of best fit predict when x is negative 10? So I'm still in trace. No, I'm not. So I'm going to hit trace and enter negative 10. That says negative 10 gives me 42 points. And one of the questions I've had, the next question that we've talked about with the groups of teachers is, can you think of an explanation of what that negative 10 minutes would mean in the context of the problem? All right, so this is how many minutes that students studied. And the thing I tell the teachers when I've worked with them is, if you're going to present this kind of a problem, I would set it up with, this is the score that students got if they paid attention in class all the time. Excuse me, I'm going to put this on hold for a second. Don't call the newspapers and report it, but I just took a drink of water. So for this is the score they got after they studied for that many minutes, assuming they paid attention in class. So the thing I've told teachers is, well, if you have a student who screws around for 10 minutes in class and doesn't study, that's going to lower their grade. It's kind of a lame answer, but it's much more fun doing it with teachers, so I hope some of you enjoyed that. What is the score at the x-intercept, and what does this have to say? Well, the x-intercept is going to be, the equation was y equals 1x plus 52. So the x-intercept is y equals 0, which would be, make your x-intercept negative 52. And if you bought this whole idea of goofing off lowers your score, that means if somebody goofed off for 52 minutes during the unit, they would score 0 on the test. But again, that's probably not likely if they actually studied something. All right, another thing to think about is what kind of questions could you add to this list? There's no way my list of questions are the only ones you could start to ask about it. All right, here, so that you can see, is the answers to the questions. And I'm going to go in and start to talk about it. I'm just going to leave that up. If you want to look at the answers or study the answers, I would suggest you go in after this is posted and re-watch this and just take a screenshot so you've got the answers printed out. I don't want to take time going over that, and I want to do some other work. The thing I'm going to do is go back into my statistics, and again, exactly how I'm doing this is in my next webinar. So if you don't know how to use e-activities, listen to my next webinar or watch for my next webinar, which is actually next year sometime, early in the next part of next year. And we'll go over how to jump around between different parts of e-activities. But I'm going to go back in here, and I want to do a graph, but I don't want to graph list 1 versus list 2, so I've got to do some other work. All right, I've had that up for a while. Here are the equations for the lines of best fit. If I have 2 outliers, I calculate the equation for the line of best fit without any outliers, with only 1 outlier, with only the other outlier, and with both outliers. Although actually one thing I do want to talk about now, as long as we've done that, one of the things, if I had that line of best fit in here, notice what happens when I have just the 50 and the 72. That's 50 studied for 50 minutes, more than anybody else, but got a low C. The line of best fit that the calculator does really twists the line of best fit compared to the line with neither of them. The slope is much lower, and the y-intercept has jumped from 52 up to 58. So it really has an impact. There's not near as much impact if you look at just the 29 and 96 outlier, at least the one I called an outlier. That raises the intercept a little bit, just over a point, and has almost no change on the slope of the line of best fit. And if you've looked at this in middle school, and if I'm an algebra teacher and I know my middle school teachers have talked about this graph in particular, at some point you might want to start to talk about with students, either in middle school or Algebra 1, the impact of this outlier on that set of data, that it has somewhat or significantly less impact, this one outlier, than that outlier. And again, compare to what happens to both. I know one of the things from talking with John Deal and a couple of other AP teachers, AP statistics teachers, the idea of the impact of an outlier and how it impacts lines of best fit or the information in the whole set of data is really something that's important in AP statistics. So again, if we preview that by saying what happens when I actually include that. So once the students, if I wanted to calculate any of those, I can go in and calculate, and that's including both sets of data. So that's this line right here. But what I'm going to do now, the second thing, is to go through these questions and look at what happened if we switched the independent and dependent variables. So I'm going to come back to that shortly. I'm going to cover this all up again. So that you're watching what I'm doing, because if you haven't done much statistics in the Prism, you set up your data. Now I want to make my score the independent variable, so I want that to be my x, and I want minutes to be my y value. So I want to look at the graph that I'm doing. I want to set up a graph. This is the graph I had to begin with marking them that way. I'm going to look at graph 2. It's a median box plot. So I set that. That's not what I want. And the list, I purposely set these up so you had to see how I can change things. I want to make it a scatter plot. I want my X list to be list 2, so I'm going to go over to F1 where it says list, and I want to say number 2 is my X list, and then execute. And I want to make my Y list list 1, so I'm going to hit F1 again and press 1 and execute. Now I've got that. Frequency list, there isn't a frequency list at all, so I need to change that to 1. And mark type, you've got 3 marks. I personally like this one. Some of you might like the X. I'm not sure about I don't necessarily like the filled in one much. Let's make those X's. The color link, if I want to show those red, 2 different red colors, I need to turn the color link on. So I'm going to have a color link, and the graph link is all set. So I've set up my graph. Now I want to select it. Graph 1 is still on. That's the original one, so I want to turn that off. Move down to graph 2, since that's the one I set up. I could have set up graph 1 just switching the 2 lists, but I did want you to see some of the other features. I'm going to draw this without changing the window, because if you go back to the original set of data, I've got this in probably not the best window to look at, obviously. So my X values, my data points, if my X values are the score, they went from 62 to 96 or 97. So if I want to set the window right, my window is wrong. That's why I've got a blank screen. So I can hit Shift, Window. All right, I always want to show some negative numbers if it's not unreasonable, because that gives me a y-axis over here so that when I go into my modify, I can see the values easily or better. So I want my x number to remain negative 15, but my highest score was 97, so I'm going to go up to 105. You could go up to 110, scale of 10, and my y values for minutes went from 10. If I just drew the graph now, I'd see this, but the lowest number of minutes was 10, the highest was 50. So I'm going to go negative 20, but I only need to go up to 60 here and hit execute and then scale. One of the things I've done, and I need to check how the calculator is set up. So I'm going to go back to the graph 2. That draws it. Okay, it's set up with that. One of the things I really needed to do at the beginning for both setups is I need to make sure that when I'm in statistics that I'm in manual mode. I'm not going to shift it to automatic. Automatic, I would not have seen either axes, and if I'm going to use modify, I really need to see both axes. So it's in manual mode. That's why when I graphed it, I get these points. Again, they look fairly linear. These are still my two outliers. I don't want to calculate anything. I'm not doing that. After middle school, when they've done some of these with scatter plots where they use the spaghetti, students use the spaghetti and figure out lines of best fit and get different answers, and then you come in and use the prism and modify. At some point in Algebra 1 or beyond, I'm going to start working with just calculate the linear regression. But again, even in Algebra 1 and Algebra 2, I'm going to give them some data points where they can't do that. So this is what I want to use as my picture in the background when I do my graph, when I do the modify. So I've got to tell the calculator I want to save this screen so that I can use it as a background in the graph menu, graph mode in the menu. So I'm going to hit the Option key, and it's important to hit Option. I can save it as a picture. I want to store it, so I'm going to hit F1 again. You can either save it as a number pictured 1 to 20 or as save as. If I do save as, I'm going to have to name it, so I'm just going to save it as a number. So I'm going to say number 1 to 20. I'm going to pick number 1, even though I know that's going to create a problem for me, but just so you see what happens, because I have some other pictures stored in the calculator. So if I hit number 1, or if I press 1 to say picture number 1 and execute, it's going to tell me that already exists. All right, so for right now, I do not want to overwrite it, so I'm going to say no. I'm going to pick Lucky 13. I think that one does not have anything. And it does not. Notice that the count up here, there was some, let's do that again. This time I'm going to put it back in 13 just so that you can point out one thing. I'm going to say pick, so I did Option, Picture, Store is F1 on all of those. F1 again for 1 to 20. I'm going to enter 13. It's going to tell me that already exists. But watch right up here, because you'll see that's going to do a little bit of movement. So I'm going to say yes, overwrite it. See how that shifted just like on your internet, whatever internet access you use when it's thinking. So that's set as picture 13. So I'm going to jump in. If I was not using the activity, I would just hit menu and go to graphs. But I am in the activity, so I've got to get out of that. I've got to go down and redo my line of best fit. Now, I still have the old picture. If I were to draw something right now, I would not get the new graph. I would get the thing I had up there last. So I'm going to do two things. I want to clear screen. of the data points. I want to go back into setup, and I hit setup is shift menu, which gets me to this screen. I'm looking for my background picture, and again, if you haven't used this before, that's what you have to do. From any screen, unless you're in the middle of setting up a window, you go to setup, which is up here, so it's shift menu, scroll down to the background. This is set up as picture 3. I don't want picture 3. This is the one. Picture 13 is the one I set up as my new background. And when I'm going to hit F1, notice the question it's going to ask me. And this is real important, and you really need to say yes to the next question, most times anyway. So the view window values for the background are going to be loaded. Is that okay? Yes, it is for me, because I want to use that same window when I do my traces. So I'm going to say yes. So now I've got picture 13 as my background. If I hit draw, it's still going to draw the same line that I had, which is a goofy line because it's still using those old values of a y-intercept of 52 and a slope of 1. Obviously, that's not the line I want anymore. One thing you can do before you show this to students is go in and say you want to modify to begin with. I want to make that 0, and I want to make the y-intercept 0 to start. So now I'm back pretty much with what I had to begin with. Now on this one, I know what the answer is, and the y-intercept is not a friendly number for students to do. So I'm going to ask the students, let's look at finding the slope first in this one. So again, different students can guess any number you want. 0.5 is not good enough, so however many guesses you want. So 0.5 is too shallow, 2 is too steep. Somebody might say 1.5. It really doesn't take too long. Now that's pretty good. That might not be bad. So let's start with the 1.5. I've got to drop my line down because I need to get this point that's way up here into this line. So let's make it negative 20. Oops, no, I don't want to do that, so I'm just going to exit. Let's look at what the y-intercept is, and let's enter negative 20. And I'm purposely going to do the subtraction sign just to re-emphasize that feature of all the Casio calculators. It's going to assume I meant negative 20, not subtract 20 from nothing. So that's not enough, so negative 40. Oops, negative 40 instead of negative 4. That's a little better. Negative 60. Negative 8. At this point in time, I would tell the students, wait a minute, your slope isn't quite right. Look, it's going up. It's not going up. It's not a good slope. So let's change the slope to get the slope a little better. And again, in fact, just to save some time, oops, 0.9, and actually it's 0.9. The slope on this is 0.989, so let's make the slope 1 again. And now that line's a little bit too low, so I'm going to guess 51 for the intercept. Negative 51 would be better. And those kind of mistakes, like where I change the slope one time, and it's a little bit hard to see, but that 1 is embedded written right over the 0 for the origin. And my y-intercept is negative 51. I can go back through all of the same questions we had before. But now this is, if I look at the slope, so the negative 51 is a y-intercept is real close to that negative 52 I had for the x-intercept the other way. The x-intercept here, if I want to do that, let's exit out of this. So now I can go in and do some g-solving. If I find the root of the equal sign, or the equation, it's 51. And with the other line of best fit, I had a y-intercept of 52. So again, now I've got minutes I have to study in order to get a 51. If I say I'm studying 0 minutes, what's my score going to be? That's the solution. That's the x-intercept here. So I'm going to get 51 as my x-intercept, which says if I don't study at all, I'll get 51 points. On the other way of looking at it, if I did not study, I got 52 points. Yes, those are not the same. It's just the difference between the calculations and round-off error and all that fun stuff. But this one's kind of nice because the first time, actually, I came onto this method with the points as the independent variable somewhat by accident, because the first time we did this in Texas, the teachers said let the points be the independent variable, and I was fine because I was just going to graph it whichever way they wanted. But after we talked about this a little bit, one of the teachers pointed out that, you know, most people are going to say that the minutes is the independent variable, and this really is an example where you can have time as your dependent variable if you want to focus on what score you get. So if I'm going to go trace and say, okay, how do I get a 70? All I have to do in trace is hit 70, and it says to get a 70, if I've paid attention in class, I need to study 19 minutes. How do I get a 90? I'm still in trace. To get a 90, I have to study 39 minutes. How do I get 100? I'd have to study 49 minutes. And before, for 100, it was 48 minutes. So it's just about the same information. You could start to talk about what happens if I study, you know, get negative scores or negative time. And again, is that even valid, and does that make sense in the scenario? Or can I get more than 100 points? Well, if you don't give extra credit, obviously that's not something that you can do, so there's nothing to talk about for numbers over 100 points. So those are the kinds of things that you can do with statistics and lines of best fit using Modify. And I think it's really a good tool for students. I've used the equivalent capability on a different company's calculator a lot when I was in the classroom. I've been retired for a while. But it's really a nice feature, and it's not only something that you can do with lines. I want to show you one quick freebie thing, because you can do Modify. I'm going to graph. When I'm doing Modify, I can only graph one line at a time. So I've got this parabola selected. I've changed the setup for my graph. Again, I'm in a different part of the e-activity, so that's why I get this different graph. I don't have the picture. That's what I wanted. The reason I had the old picture before was I went back. The reason when I started to do the second set of data the other way, I used the same line of best fit. So in here, the original picture was picture 3, and I had to change it to picture 13. In this e-activity, I don't have any pictures set up. So if I'm going to enter this one, I just want to show you one quick feature. I can do the same thing with Modify, even if I had data points that were parabolic. Or if you wanted to do something where you wanted students to explore what happens when you get different parabolas, and notice that there's a yellow one. If I go back to 1 and execute, it was 4. The yellow is in there. If I go down to H, that's my horizontal shift. If I put in 5, it shifts it to the right because it's a subtraction. I can do a lot of this. Another feature on the calculator is to do that with the dynamic mode. But I just wanted to show you a real quick thing that you can do modify. You can actually do modify with any of the built-in functions or with any function, any of the parent functions of anything you graph, not just in middle school, but all the way through high school. So that's how, again, that's how you can do some things with data points and lines of best fit with modify. Now I'm back. I've got the data points because I went back into that part of the E activity. But that's about it as far as I'm concerned. Lori, I haven't noticed. Have you noticed any questions, or are there any questions people have?
Terry, there's just one quick question.
Okay.
When you were, could you explore ColorLink just a little bit more as far as how did you exactly get the,
okay.
the pink and the...
Yes. Yep. And I'm going to go back into the data list. And just for the heck of it, the ColorLink part is two things. Number one, I have to have set a different color for the data point. So I'm going to go in and change this point's color. So I've got the 15 highlighted. Format is your color. You can change the color of your lines when you draw, the color of your y equals when you draw your functions, or when you draw x equals 7. You can make it a different color than the standard color that the calculator comes with. If you're going to do something with sketching tangent lines or anything like that, or plotting points or plotting lines on your calculator, you can actually you can change to whatever color you want that's available. So that's the format option that's on the calculator. It's in gold for number 5, so I need to go Shift 5, and just for the heck of it, I'm going to make that blue. And now the 15 is in blue. Well, if I want that whole point to be graphed in blue, I've got to change the other one. I could change the whole column at one time, but changing individual points, I haven't used this a lot, but I think this is the only way to do it, is now I've got the point 1566 as blue. That's how I got these two to be different colors. I changed that to magenta for that ordered pair, and I changed the 5072 to red. Actually, I tried some of the other colors, but I didn't like them. Let's just go back in and go to format, so it's Shift 5. I thought that the red and the blue, red and the magenta showed up best. Blue got a little bit hidden. The cyan is the same color as my grid, so that wasn't well. Yellow, the point showed up okay, but you really could not see. Yellow is not a real easy number to read for reading what the values are. And the green and the magenta were a little bit too close to the color of my grid for my tastes. So I left it, just used the red and the magenta. Now I've changed that 1 point 1566 to blue. So I'm happy with what that is. I'm going to exit. I'm going to draw my graph. I'm going to go back to, I'm in the graph mode, I'm in the statistics mode, so I'm going to go back to my graph 1. I shouldn't have done that because I've changed windows. So here's my blue point. If I go to trace, just to show you, there's the 6615 now in blue, and the other points are all in black except for the 2 reds. So that's how I do that. To actually get that to work, when I set up my graph, I have to tell it, and let's look at graph 2. I told it was a scatter plot. I said I wanted to use the X list as list 2, which was the score. So my score is now the independent variable in this second graph. My time is the Y list, is my Y variable, so I made that list 1. The frequency, there's not any, it's not group data, so I kept that at 1. I decided what mark type, and then it was off, and I turned it on so that the X and the Y values were impacted. and now it's going to color and then make sure that the color link, the graph color is linked. So that's how I got the graph to show the colors. Is that, and I meant to explain that, and I'm glad whoever asked the question asked that, and I apologize for not explaining that to begin with. Any other questions? All right, well, have a good evening. Have a great school year. Go Broncos, beat the Ravens, and take care.